donuts. Not these donuts, delicious, but these donuts with a car going in a circular pattern. So to understand these donuts, we need to understand circular motion. Circular motion is the movement of an object along the circumference of a circle or rotation along a circular path. So for this, we're going to use a toy car and understand how it goes in its circular pattern, as seen here. So features of circular motion. Circular motion is uniform motion. It is constantly changing direction. It is moving tangent to the circle, and the velocity vector is the direct tangent to the circle. Acceleration is always pointed internally. There is constant acceleration due to constant change in direction. The net force of the circle is required to obtain this motion, so our net force will always be directed toward the center of the circle. As you see here, the velocity will change direction and the acceleration will point internally. So to calculate the velocity of our toy car going in a circle, we analyze our car going and obtain the data on the time and direction of the car's movement. From our video analysis, we are going to have our radius and time, and we'll plug that into our velocity equation, which is 2 pi radius divided by time. The equation comes from the calculation of the circumference of the circle, c, or circumference, equals 2 pi radius. Distance around the circle, circumference divided by time, equals the velocity. For our car, the time it took to go around in a circle was 3.68 seconds. The radius was 1.016 meters. So our velocity calculation is 2 pi 1.016 meters divided by 3.68 seconds, which gives us a velocity of 1.735 meters per second. Now to understand the acceleration of our car, we use the same footage and analyze the direction of the car, the time, and take the information from our velocity. And as you can see, the video analysis shows the acceleration of the car constantly pointing internal. So we plug all of our information in for our features of our circular motion. Our radius is 1.016 meters. Our velocity is 1.735 meters per second, and now we just need our acceleration. The acceleration equation is velocity squared divided by the radius. The acceleration would then be 1.735 meters per second squared divided by 1.016 meters. This would give us an acceleration of 2.963 meters per second squared. So our completed features of motion for our toy car would look like so, with our acceleration being 2.96 meters per second. Woo! Now you know about circular motion.